Welcome to video lecture on Kinematics of Machinery. In today's session, we'll learn about belts. So under this belt, these are nothing but the key points. First one, length of an open and cross belt drive. Second one, power transmitted by belt. So let us start with the length of an open belt drive. So for that, let us consider the open belt drive arrangement. So here, uh, this case, this indicate the driving pulley, this indicate the driven pulley. Okay, so both the pulleys are rotated in the same direction. Let us consider R1 is nothing but the radius of the larger pulley. So this indicates the radius for the smaller pulley. So what's about this X? X is nothing but the distance between the centers of two pulleys, that is O1, O2. What's about this L? L is nothing but the total length of the belt. Okay, so our target is to find out this total length of the belt. Okay, so for that, let the belt leaves the larger pulley at E and you just see here at point G, and the smaller pulley at point F and H. So as shown in this figure, through O2. So here is that O2 point with us. Through O2, draw O2M parallel to EF. From geometry, the figure, in this geometry of the figure, we find that O2M will be perpendicular to this O1E. Let this angle MO2O1 is alpha radians. We know that the length of the belt, that is L, is nothing but, now if you just see the length of that belt, that is L, is nothing but the arc GJE plus length EF plus arc FKH plus length HG. Now this arc GJE and arc this one, if you just see here, this is nothing but the arc GJE. Now to get the complete length of this one, if I consider the half portion of this one, so if I just write here 2 into arc JE plus EF plus arc FK, the meaning is same. Okay, now from geometry, we find that here alpha, sine of alpha is nothing but O1M divided by O1 O2. So what's about this O1M? O1M is nothing but O1E divided by O1E minus total distance O1E minus EM divided by O1 into O1 O2. Now what's about this O1E? O1E is nothing but the radius of this one, radius of the larger pulley with us R1. And what's about this indicate? This is nothing but the radius of the smaller pulley. So R1 minus R2 divided by X. So we can get sine of alpha equals to R1 minus R2 divided by X. So since alpha is very small, therefore putting sine of alpha equals to alpha. So alpha equals to R1 minus R2 divided by X. We can get it here. Okay. So now the next point from this one is nothing but the arc JE. So I can get this arc JE. Arc J is nothing but the R1 into angle theta. So here is the angle R theta is nothing but the arc length. Okay. So arc JE is nothing but the, here 90 means here pi by 2. Pi by 2 plus this one alpha. Similar case with the next one, arc FK. Arc FK is nothing but here total angle with us 90, pi by 2. Here we can get alpha. So pi by 2 minus alpha. So what's about the EF? So EF, for that EF, if I just see the length for this EF and MO2 is the same one. Now if I use this triangle O1 MO2, if I use the Pythagoras theorem here, so what we get here? MO2 is nothing but square root of O1 O2 square minus O1 M square. So what's about this O1 O2? O1 O2 is nothing but the X. Okay, so square root of X square minus R1 minus R2 whole bracket square. Okay, now If I take the x common from this one, what we get here? EF is nothing but x into square root of 1 minus r1 minus r2 divided by x bracket square. Now expanding this term by using binomial theorem. Okay, so by keeping this x as it is, just consider 1 minus r minus r2 divided by x whole bracket square raised to half. Now expand this term. After expansion, what we get here? X into 1 minus 1 half will come here into r1 minus r2 by x whole bracket square plus the next terms will come occurs here. So EF is nothing but, after simplification, we can get x minus r1 minus r2 bracket square divided by 2x. Now substituting the values of arc on JE, FK and this EF into this equation number 1. Now we substitute all these things in equation number 1. So what do we get here? L equals to 2 into r1 into pi by 2 plus alpha. Just here, this indicate the r1 into pi by 2 plus alpha. Next one, EF is nothing but this term, okay, and next one FK is nothing but this term, okay. Just substitute everything here. Now just see what do we get here. Just multiply by this r1 term two inside terms. So r1 multiply by pi by 2 plus r1 into alpha plus x minus r1 minus r2 whole bracket square divided by 2x plus r2 into pi by 2 minus r2 into alpha, this way. 2 into, now just see, try to just collect the r1 terms together. Here r1 here pi by 2, and if you just see here r1 into pi by 2, this term with us. From both these terms, just take this pi by 2 as common, and whatever the remaining one is nothing but the r1 plus r2 divided multiply by pi by 2. Then next one, alpha term, and here is the alpha term with us, okay, in terms of r1 and r2. Just take this alpha as common and write r1 minus r2 here. Next, keep this x as it is, this one, this term as it is. The next one, multiply by this 2 inside term, okay. So 2 multiply by pi by 2 means here 2 get cancel, and this term will come in this way, pi into r1 plus r2. Next one, 2 multiply by alpha, 2 alpha r1 minus r2 plus next one 2 into x is 2x minus next one is nothing but the, if I multiply by this 2 term, 2 inside term, then 2 get cancel, and here in this way you can get r1 minus r2 bracket square divided by x. Now substituting the value of alpha, nothing but the r1 minus r2 divided by x from equation number 2. So equation number 2, this alpha value with us. Substitute alpha value here. Then what we get here? 2 into r1 minus r2 divided by x. We have replaced this alpha by r1 minus r2 by x. Then other terms we have written as it is. Then in the next step, this multiply by this is nothing but the bracket square. So r1 minus r2 bracket square divided by x. Other terms will remain as it is. The next step, if you just see here, this term and this one, 2 minus 1 is nothing but here 1. So r1 minus r2 bracket square divided by x. In this way, this actually term comes in terms of the radius. Now in terms of the diameter, we know the relation between the diameter and the radius, okay. So 2 times of the radius is nothing but the diameter, okay. So here pi by 2 will comes into picture because we have written here the diameter, okay. So d1 plus d2, we are replacing here radius by diameter, okay. The next one, similar case is here, d1 minus d2 bracket square divided by 4x will comes into picture in terms of the diameter. So this is the formula for calculation of the length of the open belt drive in terms of the radius and in terms of the diameter. Now we'll discuss about the length of a cross belt drive. Okay. For that, see the arrangement of the cross belt drive. Both the pulleys rotate in the opposite direction. Just here, this pulley rotates in clockwise direction, this pulley rotates in anti-clockwise direction. So R1 and R2 are nothing but the radii of the larger and smaller pulley. X indicates the distance between the center of the two pulleys, that is O1, O2, and L indicates the total length of this belt. So the length, the belt leaves the larger pulley at G and E, and use the smaller pulley at F and H. What's about the total length of the belt? For that, just here from the geometry we find that here O2M will be perpendicular to O1E. So O1E is here. Okay, just extend this line, okay. So here O2M is drawn perpendicular to O1M. Okay, okay, O1E, the extended O1E. Okay, now let the angle MO2O1 is nothing but alpha. We know that the length of the belt is nothing but here arc GKE plus length EF plus arc FKH. Now if I take the half of this one, arc JE plus length EF plus arc FK, double of this one is nothing but the total length. Okay, now from geometry, first of all get the sine of alpha. Sine of alpha is nothing but the front side with us, O1M divided by O1A2, O1O2. What's about this O1M? O1M is nothing but addition of O1E plus M. So this you can get R1 plus R2 divided by X. So for the very smaller value of the sine alpha, you can get you can just consider as alpha. So alpha equals to R1 plus R2 divided by X. Now arc JE is nothing but R1 into angle, this angle, okay, pi by 2 in pi by 2 plus alpha. Similar case with the next one, FK. Arc FK is nothing but R2 multiplied by pi by 2 plus alpha. Here one alpha with us and here pi by 2 with us. Okay, now get the EF length. EF is nothing but MO2. If I consider this triangle, if I apply the Pythagoras theorem, I can get the square root of O1 O2 square minus O1M square. Okay, so I can get the value for this one O2M from this relation. Okay, so substitute the value for O1 O2 as X, and O1M is nothing but this radius plus this one. So R1 plus R2 will come to the picture. Okay, so we can write this in this way by taking X as common, square root of 1 minus R1 plus R2 divided by X whole bracket square. The meaning for this one, X into 1 minus R plus R2 by X whole bracket square raised to half. Okay, expand this term with the help of binomial theorem. Okay, so we can get this way X minus R1 plus R2 whole bracket square divided by 2X. Now once we get the this one, this arc, and this length, substitute everything in equation number 1. Equation 1 will come in this way. L equals to 2 into R1 to bracket R1 by pi1 by pi by 2 plus alpha plus X minus R1 plus R2 whole bracket square divided by 2X plus R2 into pi by 2 plus alpha. Now just multiply by this term R1 term to inside term. Okay, and rearrange all the terms, okay, in a such a way that we can get this relation pi into R1 plus R2 plus 2 alpha into R1 plus R2 plus 2X minus R1 plus R2 whole bracket square divided by X. Now already the value for the alpha with us, R1 plus R2 by X. Just replace this alpha by R1 plus R2 by X. This way we can just substitute for that alpha, and if you just see after multiplication of this bracket with this one, we can get R1 plus R2 bracket square divided by X. Okay, and rest of the term write as it is. The next step, this minus this one, get the R1 plus R2 whole bracket square divided by X. Okay, in terms of the radius we can get this formula is the length of the cross belt drive in this way, and in terms of the diameter we can get in this way pi by 2 into d1 plus d2 plus 2x plus d1 plus d2 bracket square divided by 4x. Now we'll move towards next one, power transmitted by the belt. For that, let us consider T1 and T2 is nothing but the tension in the tight side and slack side of the belt respectively in terms of the Newton. Okay, so this is the arrangement we have considered for our study. So here R1 and R2 are nothing but the radii of driver and follower respectively. We indicate the velocity of the belt in meter per second. Now the effect of turning force at the circumference of the follower is the difference between the two tensions, that is T1 minus T2. Work done is the work done per second is nothing but difference in the tension multiplied by velocity. Okay, so T1 minus T2 into V, Newton meter per second. So what it indicate? Power transmitted P is nothing but the T1 minus T2 into V in terms of watt. Okay, since 1 Newton meter per second is nothing but the 1 watt. Now we just see the torque exerted on the driving pulley is T1 minus T2 into R1. Torque exerted on the driven pulley, that is follower, is T1 minus T2 into R2. I hope that the today's discussion derivation regarding the length of an open belt drive, cross belt drive and power transmitted, this points clear to you. Thank you.